Hello guys, in this video we are going to study about biostatic formulas present in PSM subject. I have discussed almost all important formulas that are generally asked in the PSM subject in NEETPG and INICET examinations. Right, this is going to be a very big topic, but I have discussed everything. But this topic actually tells about only the formulas. I have not discussed deep into the formulas or how to solve questions from these formulas. Right, so getting started. First of all, sensitivity and specificity, positive predictive value, negative predictive value. So this particular topic is asked very frequently in your questions, and the most frequently asked formula is this topic: sensitivity, specificity, PPV and NPV, right? So first of all, there I have made a box, right? First of all, disease positive. The disease can be positive, present, or can be absent, and the test which we are talking about, the test whose sensitivity, specificity, positive predictive value, negative predictive value we are going to check, that can come either positive or negative, right? So you can see that in the first box, disease is present, right? Disease is present in the first box. Disease is present and the test is also positive, so this box is true positive, right? In the second box, the disease is absent but the test comes out to be positive, so the disease is absent but the test comes out to be positive. This is called false positive, right? Now here the disease is present but the test tells it negative, right? So what will we tell? This is false negative, right? And here the disease is also absent and the test is also tells that it is negative, so it is true negative, right? So first of all, coming to the first formula, sensitivity. In sensitivity, what is the formula of sensitivity? The formula of sensitivity is true positive plus false negative divided by true positives, right? Next, formula of specificity. It is true negative plus false positive divided by true negatives. Next, positive predictive value and then negative predictive value. The positive predictive value and negative predictive values are, for positive predictive value, it is true positive plus false positive divided by true positives, right? The formula of negative predictive value is true negative plus false negative divided by true negative, right? So in a nutshell, if I want to tell you how can we deduce these formulas, see, always remember that in the denominator, always either true positive will come or true negative will come, right? Always these two will come. And how to deduce these formulas? It is actually very easy. For sensitivity, what you have to do, see, this is actually sensitivity, right? This is sensitivity where you have to add these two things, and I already told you that the denominator will always be this, right? What for specificity? Specificity is this, right? You have to add these two boxes and the denominator will be true negative, right? For positive predictive value, you have to use this one. You have to add these two boxes and the denominator will be true positive, because always the denominator will be either true positive or it will be true negative. For negative predictive value, it will be this, right, where you have to add these two boxes and the denominator will be true negative, right? So it is as easy and as simple as that, right? Now coming to the likelihood ratio, this particular formula is less likely to be asked, but still I am discussing it over here. Likelihood ratio. So there are LR positive and LR negative. Likelihood ratio positive and likelihood ratio negative, right? What actually likelihood ratio means? Likelihood ratio means the probability of LR positive. LR positive means the probability of positive results in a patient with disorder is how much likely than a probability of positive result in a patient without disorder, right? So what is the formula of likelihood ratio? LR positive formula is sensitivity divided by 1 minus specificity. For LR negative, the formula is almost similar. Again, you have to write specificity in denominator, and sensitivity in the numerator, right? Sensitivity in the numerator, but this time this 1 minus, right? This time this 1 minus is going to be here, right? Understood? Very easy. Now coming to odds ratio. Right, odds ratio is used in case control study, right? So again I make a table similar to that sensitivity specificity table. Here the disease is plus minus and the risk factor is plus minus, right? This particular table denotes, this particular table says that the risk was positive and disease was also positive, which means, for example, the patient smoked and the patient also had lung cancer, so I mark this as A. This particular box denotes that the risk factor was present but the disease didn't happen, which means that the patient smoked but he didn't develop lung cancer, so I mark it as B. Then this particular box denotes that the patient did not have a risk factor but still had the disease, means the patient didn't smoke but still developed lung cancer, C. And this particular box denotes that the patient didn't had lung cancer and he never smoked also, so D. So odds ratio, how will you denote odds ratio? Odds ratio is multiply these two numerators, these two diagonal things, and divide by these two diagonal things, right? So A multiplied by D divided by B multiplied by C, right? So as easy as that. Odds ratio is this particular formula, right? Next, formulas in cohort study. Now we are going to discuss formulas in cohort study. These are relative risk, attributable risk, relative risk reduction, etc., right? So for example, there is a risk factor, smoking, right? Some people smoked and some people didn't smoke, right? I take two cohorts, right? Cohort means a group of people. Two cohorts, one cohort smoked and the other cohort didn't smoke, right? Now A denotes who developed disease, B denotes who didn't develop the disease, right? They smoked and they developed disease, A. They smoked but they didn't develop the disease, B, right? Those who didn't smoke but still developed the disease, C. And those who didn't develop the disease and never smoked, D, right? So starting with relative risk, right? Relative risk, what is relative risk? Relative risk actually tells that how common lung cancer is how common is lung cancer in a patient if he is smoking, right, as compared to someone who is not smoking, right? So this is relative risk. Okay, so what will be the formula of relative risk? The formula of relative risk is I incidence, incidence in exposed by incidence in non-exposed, right? Those who are smoking are exposed to risk factor and those who are not smoking are not exposed to risk factor. So what is the incidence of lung cancer who are exposed? It is A divided by A plus B, right? And what is the incidence of lung cancer? What is the incidence of lung cancer in those patients who are not exposed, means not smoked? It is C divided by C plus D, C divided by C plus D, right? So this is your formula. If I'm going to tell you, remember this particular formula, don't remember ABCDs, right? Use logic in your question to solve this, because sometimes INICET gives questions or frames question in such a way that these particular A, B, C, D will not work. Only this particular formula, I incidence of exposed by incidence of non-exposed, will only work, right? So don't mug up these formulas, understand. Although it is highly suggested that you, after watching this video, you solve many questions from the biostat topic, only then you will understand how to solve questions, right? Or wait for the video that I will upload about questions in PSM. Second one is attributable risk. Attributable risk. What is attributable risk? Now it is very important to understand what is attributable risk and how it is different from relative risk. See, first of all, we saw that in patient who never smoked still developed lung cancer, right? Patient who never smoked still developed lung cancer. Few patients are also there who developed lung cancer even when they didn't smoke, right? So this means that lung cancer has an etiology, that is smoking. Apart from the etiology of smoking, it also has few other causes. Now in this particular cohort, we are not discussing those particular causes, right? So attributable risk means, attributable means that lung cancer is attributed how much to smoking, right? There are other causes of lung cancer also. That's why the population C is having lung cancer, because population C never smoked but still developed lung cancer, right? Why? Because there are other etiologies of lung cancer also, right? So C is not attributed to smoking, right? So attributable risk, the formula is I incidence minus I non-incident, I exposed upon minus I non-exposed by I exposed. This is the formula of attributable risk, right? So it is very easy. Again, for ABCDs, if you want to do ABCDs, it is A plus B minus C plus D divided by A plus B, right? Highly suggested that you don't remember ABCDs, you remember I exposed minus I non-exposed, right? Why did we do minus over here? It was important to do minus because by this way we are eliminating those numbers which are actually those patients who are developing cancer due to non-smoking causes. That's why it is attributable risk, right? Okay, so this particular formula is important. Next, relative risk reduction, RRR. Relative risk reduction. Now what actually is relative risk reduction? This actually means the proportion of risk reduction attributed to the intervention as compared to a control, right? So simple thing, what is the formula of relative risk reduction? Many a times INICET asks it, 1 minus RR, right? So first of all, calculate RR, then minus it by 1. Okay, minus it from 1, so you will get relative risk reduction. Next, attributable absolute risk reduction, ARR, absolute risk reduction, absolute risk reduction. What is the formula of absolute risk reduction? The formula of absolute risk reduction is I non-exposed minus I exposed. Okay, it is a bit opposite, I non-exposed first and then I non-exposed, I exposed, right? Then coming to the next formula, number needed to treat, NNT, number needed to treat. What does this actually mean? Number of patients who need to be treated for one patient to benefit, right? Number of patient, listen again, number of patient who need to be treated for one patient to be benefited is actually number needed to treat. Another very important thing, the lower the number, lower the NNT, better is the treatment, right? If lower NNT, if the value of NNT is lower, means that the better treatment is provided. And another very important thing, NNH, number needed to harm, right? If the higher the NNH, number needed to harm, is higher, for example, for smoking and lung cancer, if the NNH of smoking is very high, which means that it is safe, relatively safe, right? So what is the formula of NNT? The formula of NNT is 1 by ARR. And the formula of NNH, number needed to harm, is 1 by AR, right? Extremely important. Don't forget these two things. Extremely important, right? Now we have completed the cohort study formulas. Now coming to incidence and prevalence. The formula of incidence and prevalence is, for incidence is number of new cases divided by total population at risk. Very important, total population at risk. Now this at risk thing is very important. You will not take whole population. For example, a particular person who has already developed measles will never develop measles again, so you will not put that particular person in the denominator because he or she is not at risk, right? The formula for prevalence is total number of existing cases divided by total population. Now I have written over here total population, not total population at risk, right? So in prevalence you will include the whole population, you will not include only at risk population, right? One thing I forgot to develop in the cohort study part, forgot to tell you about the cohort study part, is PAR, right? What is PAR? Population attributable risk, population attributable risk. The formula is incidence in total population minus incidence in non-exposed divided by incidence in total population, right? So in the above formula, what is the incidence in total? The incidence in total was A plus C divided by A plus B plus C plus D. This is incidence in total, minus incidence in non-exposed is, non-exposed was C plus D, by incidence in total, right? A plus C divided by A plus B plus C plus D, right? So again I'm telling you, do not remember these A, B, C, Ds, right? Always remember the formula IT, INE, that thing, right? Now one more thing, AR percentage. AR percentage is actually relative risk minus 1 by relative risk into 100, right? So this is AR percentage. Now coming to central tendencies, the easiest part and the easiest of all, right? Everyone must be knowing it. First of all, for example, if you are given a particular data, I have shown over here, arrange. First of all is arrange from less to high, right? So first of all there is 1 2, then there are 3s, there is 2 3, then 4 4 4 4 4 4s, then 5 5, so I think there is only 2 5, then 6, only 1 6, then there are 2 7s and 8, 1 8 and 1 9, right? So I have arranged it completely in a proper manner. So what is the mean? First of all, mean. Everyone of you must be knowing what is mean. Add all of them and count the total number of sums, right? Total number of samples given, 1 2 3 4 5 6 7 8 9 10 11 12 13 14, right? So add them up and then divided by total sum, you get the mean, right? Then median. What is median? Median is the middle value. Median is middle value, right? So the middle value in a even number population, in a even number, you will get a proper middle value. right? So for example, let me explain this. There is a value 3, sample value 349. So the median of this particular data is 4, right? Middle one. But for example, there is 3449. What will be the middle value? Of course, there is no middle value, right? So you will take these two numbers, 4 plus 4, and divided by 2, right? Again 4, right? For example, 3, 6, 8, 9. What will be the median value? 6 plus 8 divided by 2, right? 14 divided by 2, it is 7, right? So this is how median is actually calculated, right? So in an odd number data, it is very easy to calculate the median, but in here the total number of values is 14, so there is actually no median value. So in our discussion, what will be the median value? Let's see. 1 2 3 4 5 6 7, right? Just somewhere here the median should be there. Then 1 2 3 4 5 6 7. So 4 and 5 are the median values. So 4 plus 5 divided by 2, 9 divided by 2, 4.5. 4.5 is your median value, right? What is mode? One with maximum frequency is mode, right? So the one with maximum frequency actually is 4, right? 4 is the maximum frequency. There are 4 4s, right? So the mode is 4. Very easy. Now coming to a formula, mode is equal to 3 median minus 2 mean. Sometimes it is asked in our examinations, right? Mode is equal to 3 median minus 2 mean. Now coming to biostat proper, standard deviation. The another name of standard deviation is RMSD, root mean square deviation. Sorry, right? The root mean square deviation, RMSD. So how it is calculated? It is the whole root of summation of square of all deviations divided by total number of samples. So this is standard deviation, right? Remember. Then we coming to standard error. Now this particular thing, standard deviation, was asked in INICET May 2023, the one which I gave, right? This particular formula was given and they asked what the formula belongs to. Now many people actually made mistake. They didn't answer standard deviation, they answered standard error, right? So it is very important that you may be thinking that these formulas are useless, these formulas are less asked, but no, right? You have to remember these formulas very properly and differentiably. Now standard error. Standard error formula is very easy. Standard deviation, the one given above, divided by root n, right? Then standard error, difference between two means. Now there are two means given. If there are two means are given, which means that there will be two standard deviation and two samples, right? So first of all, for the first sample, square of standard deviation of the first sample divided by n1 means total number of samples in the first sample, in the first set, plus standard deviation of second sample square divided by total number of sum of samples in the second set, divide and this whole root, right? So this is the formula of standard error, difference between two means. Now standard error of proportion. The standard error of proportion is PQ upon N, right? In the question you will be given, for example, 40%. So P will be 0.4 and Q will be 1 minus 0.4, which means 0.6, right? So in this way actually you solve this question, and N is total number of samples taken in that data. Then standard error, difference between two proportion, very easy. P1 Q1 by N1 plus P2 Q2 by N2 and whole root, right? Next, coming to precision. What is precision? Now see, precision is actually opposite of error, right? Opposite of error is actually precision, which means that precision is inversely proportional to standard error and standard error is directly proportional to this, right? Or we can say that the formula of standard error is sigma upon root n, right? So the formula of precision is root n upon sigma. Very easy, right? So this is the formula of precision. Now coefficient of variation. For the coefficient of variation, COV, coefficient of variation, it is standard error, right? Standard deviation divided by mu into 100, divided by mu into 100, right? So what actually is mu? Mu is nothing but mean, right? Mu is nothing but mean. Okay, now coming to variance. The formula of variance is this, right? Standard deviation square. Now relative deviate. Relative deviate is shown like this. The formula is x minus mu divided by standard deviation, right? This is the formula of standard deviate. Now we will take an example to understand how to calculate the relative deviate of a particular data, right? For example, there are n is equal to 100. There are 100 people, and all this particular data of 100 people is a normal distribution curve. Normal distribution curve, and this particular thing is actually the data of hemoglobin. The mean hemoglobin in all these 100 people is 13.5 gram per deciliter, and the standard deviation is 1.5 gram per deciliter, right? Now you have to find the relative deviate relative deviate of the patient whose hemoglobin level is 15.0 gram per deciliter, right? So what is the formula? It is x minus mu by standard deviation. Now what will be x? X is 15, right? Because for this particular value you have to find what is mu. Mu is mean, right? Already told you mu is or mean is 13.5 given in question, and standard deviation is 1.5. So it comes out to be 1.5 divided by 1.5 is equal to 1. So your relative deviate is 1. Relative deviate for a person whose hemoglobin is 15, then his relative deviate will be 1. Now next thing, normal distribution, extremely important, very important topic. Okay, normal distribution. So you all must be knowing this particular thing. I'm just making you remind these stuffs, nothing else. First of all, this is mean, and this is minus 1 standard deviation, this is plus 1 standard deviation. Now this point denotes plus 2 standard deviation, this point denotes minus 2 standard deviation, this is minus 3 standard deviation, and this is plus 3 standard deviation, right? Now from mean to plus 1 standard deviation, there are 34% population, and this side also 34%. Now here it is 13.5%, means 13.5, and again there is 13.5%, right? 13.5%, right? And then there is 2%, and then there is 2%, right? So which means that mean plus minus 1 standard deviation means mean plus minus 1 standard deviation. This whole area is actually 68%, right? This whole area is actually 68%. So 68. Then mean plus minus 2 standard deviation, which means this whole area is actually 95%, right? Then mean plus minus 3 standard deviation, it is 99%, right? There are very good and very important and beautiful questions that can be framed in this particular topic, right? So solve these questions related to this, but for solving these stuffs you need to remember this particular thing, nothing else, right? These particular percentages are important. Okay, now confidence level. There is important for understanding confidence level, we have to first understand the null hypothesis part, right? We have to first understand the null hypothesis part or the statistical errors. So coming to statistical error, right? This is a whole different topic, and we are going to invest some time in this particular topic, statistical error. So first of all, I make again a box, right? Reality and based on trial, right? I am again telling you, I'm not going to discuss many things about this particular topic. I'm only here for giving you a list of all the formulas, but still I'm going to explain a few things. So for example, I'm conducting a test about a particular drug, for example paracetamol, right? I'm comparing paracetamol with my new drug, for example drug X, and now I'm seeing whether drug X is better than paracetamol or not. Now I will take a null hypothesis, H0, right? What will be the null hypothesis? Null hypothesis means that drug X is not better than paracetamol in decreasing the fever, right? So this is what null hypothesis. So based on trial, now I am doing a trial, right? Now based on trial, I see that I am telling you, based on the trial, I am telling you that drug X is actually better than paracetamol. Now what does this mean? I am telling you that drug X is better than paracetamol, which means that I am rejecting null hypothesis, right? I am actually rejecting null hypothesis. This means that I am rejecting null hypothesis, right? But in reality, null hypothesis is true, which means in reality, null hypothesis is true, which means that drug X is actually not better than paracetamol. But based on the trial, I am telling you that drug X is actually better than paracetamol. Now what is this? This is called type 1 error. Type 1 error, right? Or alpha. Okay. Now there can be another reality also in parallel universe. There can be another reality that null hypothesis is false, which means that actually drug X is actually better than paracetamol, and based on the trial, I am telling you that drug X is better than paracetamol, which means that there is no error, right? Now based on the trial, for example, I am telling you that I am accepting H0, right? Accepting H0 means I am telling you that yes, drug X is not better than paracetamol, and in reality the H0 is true, which means reality also is telling you that drug X is not better than paracetamol. So again, no error. Now coming to the another error, right? Here in this particular table, I am telling you that in reality H naught is false, which means I am telling you that paracetamol is actually, drug X is actually better than paracetamol. But based on the trial, I told you that I accepted H naught, which means that I am telling you drug X is actually not better than paracetamol. Then of course it is an error. Again, I have done an error. So this type of error is called type 2 error, right, or beta. So now you are ready to understand confidence level, right? So what is confidence level? Confidence level is 1 minus alpha, right? What is alpha? It is a type of error. So if we do, if we minus alpha from, if we deduce alpha from 1, so it means confidence level. And what is par? It is 1 minus beta. It is another type of error we already saw above. What is confidence interval? How will you calculate the confidence interval? Very easy. The formula of confidence interval is mean plus minus z multiplied by standard error, or we can also tell mean plus minus z standard deviation upon root n. I am expanding standard error, right? For z for 90%, if I am telling you calculate the 90% confidence interval, then z for 90% will be 1.64, right? Z for 95% is actually 1.96, right? And z for 99% is actually 2.6, right? For calculation purposes, you will take it as 1.5, you will take it as 2, and you will take it as 2.5, right? And for memorization purposes, right? Now, degree of freedom. Degree of freedom is actually calculated in chi-square test, right? In chi-square test, there is a table. The table contains rows and columns, right? So what will be the formula of degree of freedom? The formula is row minus 1 multiplied by column minus 1. So this is the formula of degree of freedom. Now coming to sample size. The last thing that I'm going to discuss over here, sample size, right? How to calculate the sample size of any data. What does sample size means? Sample size actually means that for calculating anything in a particular test I'm conducting in a data, what should be the minimum sample size that I should take, right? So the sample size formula is 4p q divided by L square, right? What does p mean over here? Prevalence. P here actually means prevalence in previous studies. P is actually prevalence in previous studies. Q is 1 minus p, and L is maximum permissible error, which is actually 5%. If it is not given, you will take it as 5%, right? For example, the prevalence of candida is actually 15% from a previous study. Minimum sample size you have to calculate. What will be the minimum sample size you have to calculate to find the current prevalence of candida, right? So prevalence of candida is 0.5. What will be the minimum sample size that I have to take to calculate the current prevalence? So what is the formula? It is 4pq upon L square. So 4, what is p? P, I already told you that p is prevalence in previous study, so it is actually 0.5, 50%, right? What will be q? 1 minus 0.5, again 0.5. And what will be L? L is taken as 5%. 5% means 0.05, right? 0.05. Don't take it as 0.5 and whole square, right? So you will come out with an answer of 400. So minimum sample you have to take is 400. Now coming to the last formulas, odds. What is the formula of odd? Probability by 1 minus probability. And what is the formula of probability? It is odds by 1 plus odds, right? So this is the whole topic I have covered over here. It is a very big video. A lot of formulas I have covered over here. I greatly appreciate if you are here till the end. And what I actually did in this particular video is jotted up all the particular formulas that are important in the PSM subject and taken it or accumulated in this particular video, right? So thank you for watching, guys, and thank you for watching till now, and make a list of it